Homework 12, Section 6.2, Combinations in the Binomial Distribution, Video 3. Before we talk about a binomial distribution, we need to talk about what constitutes a binomial experiment. A binomial experiment has four features, or characteristics, or requirements. Number one, a fixed number of trials are conducted. For example, flip a coin 12 times, not flip it until you get 7 heads or flip it until you have more tails than heads. It's flip it 12 times. However many times you conduct the trial is called N. Number two, each trial has the same two outcomes. That's why this is called binomial. The two outcomes are labeled success and failure. Now, it's important to emphasize that in the context of probability and statistics, a success is not necessarily something that's good, and a failure is not necessarily something that's bad. Success is just the word used to designate what we are looking to happen, and failure is used to designate the other outcome. So for example, when we flip a coin, we could say that I want heads, so a head is a success, whereas a tail is a failure. Number three, the probability of a success and failure is the same for each trial. I probably should have worded that differently. Let's just say the probability of a success is the same for each trial. I don't want to imply that success and failure have the same probability. What I was trying to say is that for each trial, the probabilities remain the same. For example, if the probability of a success is 25%, in the first trial, then it should be 25% for every trial. Now, if there's a 25% chance that you succeed, what's the percent chance that you fail? 75%. So really, I only have to say that the probability of a success is the same for each trial. That probability is usually called lowercase p, and the probability of a failure as a consequence is 1 minus p, because success and failure are complements in this context. And number four, the trials are independent, meaning the outcome of one trial does not affect the outcome of the next trial. So here's an example of a binomial experiment. Let's say you're taking a multiple choice test and it has 10 questions. So 10 would be the number of trials, n equals 10. To pass, you must answer 7 or more correctly. If you guess, you have a 25% chance of guessing the correct answer, meaning that there are 4 answer choices for each question, one of which is correct. So this would be an example of a binomial experiment. There are 10 trials. Each trial has 2 outcomes. You guess correctly or you guess incorrectly. Which is the success and which is the failure is irrelevant, but I think we could all agree in this context, guessing correctly would be the success. The probability of the success is the same for each trial. Yep, 25% chance of guessing correctly each time. And the trials are independent. Assuming that the questions are not related to each other, your guess on one question should not impact your guess on the next one. So this actually is a binomial experiment. But the question that we're going to answer in this context is, what is the probability you pass? We'll have to do that in the next video. So contextually, what is the probability that you correctly answer 7 or more questions if you just randomly guess at each one? Think about what that answer might be, and the real answer might surprise you. In order to do this, we got to figure out how to calculate the probability of getting 7 correct, or the probability of getting 8 correct, or the probability of getting 9 correct, or the probability of getting all 10 of them correct. In order to do that, we need to know what's called the binomial distribution formula.